This is ISO OSI reference model. In the interview itself, people are making, I am seeing a lot of even YouTube videos, those who teach CAN in the YouTube, they make these mistakes. While they are delivering it, they say all 7 layers of OSI is implemented in the CAN. That is wrong. In the hardware level, in the VLSI logic, they used to program that CAN is a peripheral. Already I told it is a part of a circuitry in your chip. In that circuitry, only 2 layers of OSI is implemented, data link layer and physical layer. Rest of the things are not implemented in the VHDL or VLSI logic. For that, you have to write your program. You have to write your microcontroller program for rest of the layer from layer 3 to 7. Only 2 layers are implemented in peripheral itself. For that, you don't need to write any program, physical layer and data link layer. When you attempt for interview, don't tell like all 7 layers are implemented in the CAN standard. No, that is not the true. Only 2 layers, physical layer and data link layer are implemented in the CAN. It doesn't mean that when you say like that, it doesn't mean that the rest of the layer you cannot program in for a CAN product. You can do it. You have to do a microcontroller program. So you have to write a program for them. For these two, you don't need to write anything. That is the thing. Only by doing a configuration, you can use that layer. Is that clear? This ISO OSI reference model.
Yes.
Layered approach in CAN. They divided this layer partially implemented by higher layer by HLP. Then they have a division in that. In that, there are 3 layers they have developed. These layers are within this data link and physical layer, I believe. Only the logical link and physical layers are described. The data link layer is divided into 2 sublayers, logical link control and medium access control. The LLC sublayer deals with message acceptance filtering, overload notification, and error recovery management. These are taken care by logical link control. Max sublayer present incoming messages to LLC sublayer and accept the messages to be transmitted forward by the LLC sublayer. It acts like an interface. Max sublayer is responsible for message framing, arbitration, acknowledgement, error detection, and signaling. All these things are taken care by that. This is part of data link layer. Max sublayer is supervised by a fault confinement mechanism. Physical layer defines how the signals are actually transmitted, dealing with the description of bit timing, bit encoding, and synchronizations. CAN bus driver bar receiver characteristics and the wiring and connectors are not specified in the CAN protocol. So they don't say like the characteristics of wiring and other stuff. They are not covered in the standard. You can choose the physical link that you want. System designer can choose from the several different media to transmit the CAN signal. Whatever that I discussed now in this text, right, that was brought into a block diagram like this. You have application layer, that is the top, and then these are the CAN layers. Data link LLC sublayer, it does acceptance filtering. Acceptance filtering means whether I have to take the message or not. That will be taken care by this filter. Overload notification. When there is a overload, that is to send the overload frame, will be taken care by the logical link only. Similarly, recovery management. You went for bus off and then you are recovering back. That recovery will be taken care by this one. Then the max sublayer does all this stuff. data encapsulation, decapsulation, frame encoding, stuffing and destuffing, medium access management, error detection and error signaling, acknowledgement of the message, serialization and deserialization, converting to serialization and deserialization, convert them into parallel. All those things are taken care by max sublayer. Then we have a physical layer. Physical layer does the following, like bit encoding, body decoding, bit timing, synchronizations, all this stuff are taken care by this. These two layers are managed by fault confinement mechanism and then the bus failure management. They are supervising things. All these things are like for a system testing engineer, these are not required to know unless you are doing some product development using the CAN chip. But it is good to know about them. Like you should have a clear picture about what is happening in a CAN issue. That's why I gave all these things. But for these things, you won't deal with that chip level, because for that, all these things should be known to a person who designed the chip, who designed the CAD circuitry, and then who does program for it. As far as system engineer, if you know the concept, that's enough. I believe I have given enough information about the CAN basics. With this, the basics CAN 2.0 standard is over.